Hello, everyone. We'll be speaking about mastering the full spectrum of failures. And let's just begin. Fantastic, I have the laser. So before we dive right into it, a few words about myself. So I'm the CTO of Razor Labs. I founded, together with my partners, 4 companies overall. These 4 companies were all bootstrapped, so it was a quite unique journey. Today, these companies are a bit more than 350 team members working in different sectors. So resources is one of them, and is what Razor Labs is about that we're going to present. And actually, we IPO'd 2 of these companies. One of them just recently. Razor Labs was IPO'd 3 years ago. A bit about my journey in mining, our journey in mining. So really, we've been in this sector for more than 10 years. In these 10 years, my colleagues and I visited, I believe, more than 100 sites across all major continents, from Australia, South Africa, DRC, Latin America, North America, and others, and really engaging all stakeholders, really from the maintenance managers, their superintendents, site leaderships, and up to global COOs of entire organizations. And what I want to share in this session is how can we really capture the full spectrum of all the failures. But before we get to this one, when we actually started this journey 10 years ago, we asked ourselves, why are there even failures? Because sites use so many technologies, why do we still have failures despite all of these technologies? And the first thing that we've actually done is we actually mapped what are the technologies that are used, at least the main technologies that are used by sites today. And I guess you're all familiar with these technologies. SCADA would, I guess, be the number one. It's the 101 of every site operations. In SCADA, obviously, you have the alarms. Next would be the historian that the SCADA is connected to, holding not only the alarms, but also the raw data. Next would be periodical vibration and oil analysis, right? Every 1 or 2 or 3 months, performed naturally on sites and converted into reports that are submitted to the sites. And lastly, if I now speak about the mobile fleet, very similar methodology of alarms taken from either MineStar, MineCare, depending on the OEM of the mobile fleet. So why, despite all of these technologies, very advanced ones, why are we still having all of these failures and in such substantial quantities on site with such substantial implications, financial implications? The way that we look at it is we kind of look at the failure modes as an ocean. And we try to see what is even covered today in this ocean and what is not covered, maybe even more importantly. So the first thing is all these vibration oil reports, right? That's a part of the ocean. But then when we actually dive into this one, we actually see that, okay, these reports are generated every month or 3 months. By definition, all the failures that happen in between, they deteriorate faster than a month, would not be captured. Second of all, if I have a human error in my maintenance, I have a commissioning error, I would never go, or I would never succeed to get to my next maintenance or periodical inspection. I would have the failure before that. Then we have everything that cannot be covered by vibration or oil. If I have a belt trip, if I have a pump performance issue, a pressure drop, it cannot be seen in oil and vibration. I'm just not going to be able to see anything there. And finally, I might be able to see it in the vibration, but I have so much noise because my mill is grinding ore, my crusher is crushing ore, and that noise actually masks the failure from actually being apparent in the data. And that's just for the periodical inspections. Then I have the next one, which are basically all the alarms, right? SCADA alarms, mobile fleet alarms, and so on. And here we have 2 limitations. One is, by definition, they only work on the sensors on site. Any other failure that is not covered by these sensors, like visual failures, like we're going to see in a moment, by definition would not have any alarms. And that goes both for fixed and for mobile. We can see, for example, in sites that the OEM sensors only cover so much, and roughly a quarter to a third of the failures cannot be covered with the existing mobile fleet sensors. In fixed assets, the percentages are much larger, and actually most of the failures cannot be covered by the sensors that are actually connected to SCADA or historians. Then we have two last factors. One factor is these alarms need to be manually investigated. And I have thousands of these alarms per day, 500, 700, 1,000, depending on how large is the site. The site team has 2-3 people looking at these alarms. There's so much they can do. They cannot look or investigate 1,000 alarms per day. By definition, many of these alarms go through, turn into failures. But lastly, even if I capture this alarm and I turn it into a work order and I prescribe the actions, if these actions are not correct, if they're not addressing the root cause of that failure, I'm going to see that failure again, and it will cause downtime. In practice, that ocean is actually much larger, and actually most of that ocean is red. 75% from our experience, depending on the site and so on, but up to 75% of the failures actually happen because of, or despite all of these systems. So I might have Mindcare on site, I have SCADA on site, I have historian on site, I'm doing my monthly vibration and oil checks, and still I would not be able to capture most of my failures, which is a pretty dramatic finding that we had when we actually started working on our system in Razor Labs. And that's not a slogan. It converts into real financial impact. It's millions of dollars per site per year. I'm going to give here an example that we got from one of the sites. You can see here as rows, I'm going to go through this one quickly, different failures that were found that were not covered by all of these systems. And what you see here on the columns are the financial impacts according to different KPIs. So spare parts cost, downtime cost, labor cost, and so on. And that's real numbers taken from a cold site. It's their numbers. And you can see more than $1 million of value on only 4 months of 10 machines. And now extrapolate it to hundreds of machines, to many sites, to years and years and so on. You get to immense value. So now the name of the game is, how can we actually reach holistic coverage? How can we cover these 75% that are not covered by the current systems? And that's what I'm going to speak in the next few minutes. And imagine it's like a puzzle that you're trying to cover the entire board. So first of all, how can we get from 800 alarms per day that needs to be manually investigated into, 5 root causes of real deteriorations that, I can go and handle 5. It's not a problem. And this is a real example from a Caterpillar truck where you can see here basically spikes that they had in their atmospheric pressure, engine oil level, and engine oil filter, each of them generating its own alarm. It's very easy to be confused and to try and go inspect the oil system because that's where the alarms come from. But a reliability engineer and our system, they know that all of these sensors are actually connected to the same circuit in the engine harness. So they actually know that, no, I don't need to waste my time on going there. The problem is actually my harness, and that's what I need to repair and to inspect. So despite these symptoms being these noise and these spikes, the root cause is actually the engine harness, and the recommendation, therefore, is go ahead, inspect it, and repair it. So you can kind of see how dozens and dozens of false alarms that would literally mislead the team to go to the oil system now became a single diagnosis of a real root cause that once they do it, that's it. All of these would be just gone. So now I'm starting to cover my puzzle, and the first one is automated root cause analysis. Don't give me thousands of alarms or false alarms per day. Give me 5 real deteriorations. Give me the root cause and the actions so that when I actually do them, I would not see that failure, not only now, but also in the future. I would not have any recurrence of that failure. Second thing is all that noise. Mining is noisy. I'm crushing ore, I'm grinding ore, I have haul trucks on unpaved roads and so on. That noise is causing lots and lots of problems. Not only false alarms, but also masking real deteriorations. In haul trucks, when an OEM already files an alarm, in many times it's too late. It means that there's already damage to the component. That's another case from a CAT truck where you can see deterioration in transmission loop temperature. And that's the real data of that loop temperature. Look how noisy it is. Here they had an anomaly and OEM alarm. In that point of time, there's already damage to the transmission. That transmission would not live a full life. Why is there noise? The noise is because I have different payloads, different engine loads, different RPMs, different gears. All of that, all of these operational changes induce a lot of noise to the data. We can use AI to remove that noise, to compensate for all of these variations, and to turn that noisy data into a clear trend where you can see that phenomena a month earlier before there is any damage. Now imagine this one for engines, for tires, for transmissions. Preventing that damage prolongs the life of the equipment and reduces these very expensive replacement costs. And now we can do this one not only for the mobile fleets, but also for the fixed assets. Ball mills are today more important than ever because of the high gold and copper prices. When they stop, sites lose recovery period. There is no redundancy for ball mills. And in this case, we're showing how the same methodology was able to find failures that otherwise would not be detected by any other system because of that high noise. In that case, the site had a long shot. During that long shot, these are these black points, they had a human error. They forgot to rotate the mill. That error led to damage to the bearings. Because of the sheer weight of the mill, it just caused damage to the bearings. Once it went to orange, you could already see that deep diagnosis. It's called false Brinelli. I'm not going to go into this one. But we're giving them the real root cause analysis of what's happening in a failure that would otherwise be unnoticed. And I'm going to now explain why. In our system, they can actually see the evidence. They can see that in a single month, some specific frequency, doesn't matter, deteriorated by 40 times. The site GM was surprised. They sent their own vibration analyst to take the same readings. That's what they got. Completely noisy data. You try to compare the red to the blue, also 1 week apart. You don't see anything. So that failure is just completely unseen in the regular information. They took our word for it. They actually went ahead, took apart the old motor in a planned manner, right? Put a new motor in, took it apart, and they've seen that real severe damage to the bearing that would have caused days and days of shutdown. You need to bring a crane in the middle of the night. It was also near Christmas, a complete nightmare. Here, it was completely avoided. They replaced it in a planned manner. A few weeks afterwards, they had plenty of time to spare. Now, how do we turn this one into that one? What did we do differently that they did not do? So very simply speaking, just like the truck, the mill also has operational variations. It has more ore, less ore, spinning faster, spinning slower. All of that induces a lot of noise. Our system automatically always tracks the machines under the same operational conditions so that all of that noise is removed. And on top, we apply other algorithms like envelope demodulations and others that I don't have the time to go into to completely remove this noise. So now all of this noise allows me to see failures that I did not see before and get another piece of the puzzle to cover all that red ocean of failures. Lastly, and that's the last thing we're going to cover, is visual AI. Visual AI allows us to track deteriorations that are invisible by any other sensor, from out-of-spec ore at the discharge of crushers to misalignment of belts that shrink their life by a factor of 3 or even 4, variations of volume, blockages, and even rips of the belt. If I, for example, look at out-of-spec ore, we're measuring every rock at the discharge of crushers and so on, and we're basically trending the oversize so that once it goes up, they proactively go ahead, replace their liners, calibrate their gap, and they do it proactively before it causes downtime and failures and so on. This is an example of something that cannot be detected by any other sensor, and it's just missed with the sensors that are today deployed on sites. Very similarly, misalignment of conveyors. You buy a conveyor belt, the same conveyor belt can last 5 years or 10 years or 2 years, and misalignment has an immense effect on the lifespan of that belt. There are dozens of belts on site. It's impractical, again, for a person to track each and every one of them 24/7. So we do this one automatically by measuring the distance between the belt and the tips of the rollers. When a belt is misaligned for a few hours, no worries. They go ahead, they align it, and they prolong the lifespan of these very expensive pieces of equipment. Now, same goes for flotation cells in gold or copper or coal. They have an immense effect on the recovery. It can be the difference between 3 grams of gold from the same ore or 2 grams or 1.5 grams. What we're doing is we're tracking the size and the color and distribution of the bubbles to make sure that the recovery is always optimal. Again, no other sensor can look at this pattern. And maybe lastly are splices and clips of the belt that require today actually stopping the belt, losing production, going dozens of kilometers manually to inspect them, and instead we can put a high-speed camera before the loading, before the shoot, and just do this one real time in an online manner while the belt is operating regularly. So this is another example of failures and root causes that can be found only when new but very simple sensors are added to the site. Here we took the example of cameras because we only have 20 minutes, but you can start now imagining that if I'm able to map all the failures to what sensors are required, sometimes a very easy installation of a few additional sensors can really dramatically increase the coverage of the failures. Just like a doctor is not limited to only blood work or only CT or only MRI, but they're using all of these imaging techniques and blood work and so on to holistically look at everything that can go wrong. This is our methodology. We're like automated doctors for machines. We're going to look at everything together and combine it to make sure that we give the right diagnosis. There are several things that I don't have the time to cover. I'm just going to mention them briefly, and then we're going to end. One is maintenance effectiveness. Human errors in maintenance or commissioning and setup errors are also a major cause of failures. We're able to ingest maintenance information and correlate it with the health of the equipment and basically flag when a maintenance was either ineffective or some error actually caused it to deteriorate. Currently, it would lead to failures because the machine would not make it to the next inspection, which is in a month's time or 3 months and so on. And lastly is also tracking the operator behavior of mobile fleets. That operator behavior has an immense impact on the lifespan of the components because improper driving and abuse of the equipment can shrink dramatically by 20, even 30% the lifespan of engines, transmissions, tires, obviously, final drives, and so on. And we're actually tracking this one as part of our methodology to really make sure that everything is covered and the puzzle is complete. So that's the product that we've built over the past 10 years, and that's our methodology. How do we take this red ocean of all the failures that happen despite the current solutions and turn them into a green ocean where everything is covered and the site can really see the value from day one. That's basically it. Thank you very much for listening. You're very welcome to also visit us at booth T15, Razor Labs. Thank you.